Good afternoon, everybody. I am the Chief Environmental Strategist for Microsoft, and what that means is I think about the intersection of a couple of different societal trends that are happening. So you can look at these headlines. I don't think any of this will be a surprise to you, especially here in this part of the world. I travel all over the globe, and I used to say that the world was largely asleep about the environmental degradation happening across all of our systems simultaneously. I think the world is almost awake, but I think we are still underestimating the speed at which the degradation of the planetary systems are happening. And so when we talk about the timescales, 2020, 2030, 2050 goals around energy and carbon, I think we're going to find ourselves in a situation within the next few years where we are actually revisiting the speed at which we must transition. And so we're kind of awake on this issue. The other thing that I think people underestimate is the impact and the scale of what's happening with things like artificial intelligence, machine learning, computing at the edge, IoT, all these kind of terms, but really what they mean is ubiquitous computing, commoditization of things that were super complex. I go to a lot of meetings where people say to me, in the utility industry, but in all industries, well, we can't get good data scientists, we need AI experts on our staff. Companies like Microsoft or Google or Facebook, you're stealing all of those people from our industry, right? The reality is, if we do this right as an industry, you just go do what you need to go do and ask the questions you need, and AI becomes a commodity-based functionality. Right? It's kind of like the rules engines we all used to have to write, at least in my generation, around things like email and downloading files over the web with the FTPs, like going way back. Now that seems ridiculous. I point at my TV, I have my phone, I download what I need. I don't need to be a digital expert. And so the speed of transition happens incredibly quickly. So this was my first set of electronic devices. These are US numbers, but they probably weren't far off. My first US telephone was $1,500. I had a brick about this big in the back, so I could actually get connectivity. And my first monthly bill was $800. Right? Now I can get one of these phones that I can drop in water if I'm in a developing nation, or here even, for about 25 US dollars, I can get a phone that connects me to the web. Right? So the speed of transformation is actually way faster than it was when this revolution happened. So I think when we say, hey, 2030, 2050, are these things possible? I think they're actually absolutely possible. And so now the question is, what do we do to change it? So my team has a mission, right, which is empowering every person and organization to thrive in a resource-constrained world. And the reality is, and I won't go through all the details in the interest of time, but whatever system you look at today, it is on the verge of collapsing. Species extinction, needing 40% more water than the planet has available by 2030, feeding 9 billion people, and the list goes on and on and on, and giving people who don't have power access to power. So how do we think about this intersection of AI, technology, planetary issues? I'll just give you a couple of examples, and then maybe later in the Q&A or afterwards we can talk about some more. So the first place for us is carbon. And in each area that we think about these issues, Microsoft first says, what are we doing ourselves? Before we go talk to our customers, we better take a step back and think, what do we do for ourselves? So in the area of carbon, we've been carbon neutral, and we tax every division at the company for carbon for the last 7 years. And we go, that's great. Microsoft's about 2.5, maybe coming up to 3 million tons of carbon, so it's not insignificant. And we use as much energy as a small US state. Microsoft on a global basis uses more energy than the state of Wyoming, the state of North Dakota, the state of Alaska. We're a big energy consumer. But even when we get to 100% renewable energy, it doesn't matter on the global scale if we're not changing the way systems work. So that's where our operational goals come in and says, how do we think about this at a global level? That'll just give you some scale about what we do on the environmental side. Again, I'm happy to answer questions about it. But really what we have to do is take a step back. How many people here file or do something around carbon disclosure on an annual basis? Okay, so a few of you. So the way this works, for those of you who don't understand it, is Microsoft and every company around the world says, how many kilowatt hours did I use in every location, including Denmark? And at the end of the year, I'm going to take that gross kilowatt hour consumption, and I say, what was the grid average in Denmark for that year? I'm going to multiply kilowatt hour times average consumption. Now, as we've heard and as we know, the grid goes like this all day long, right? Renewable, not renewable, renewable, not renewable. So the problem is I'm reporting a number that I know is inaccurate, but I've never had a system that allows me to say, how do I optimize? So it's like me asking you, optimize your stock portfolio and your bank account, and it takes 6 months to get the data, for January of 2017, and I'll give you the data in June 2018. That's the way we actually behave as a society. And we say, we're going to reduce carbon by 20, 30, 50, 80%. But I really don't know what my carbon balance is on a daily basis. I don't even know it on a weekly or monthly basis. So we got to change that. So what we did is we wrote a piece of software. This is a US example, but it's all over the world, that basically says, here's what's happening on the grid. Here's the average. Here are the different plants that are feeding into the grid right now. So if we wanted to go do some workloads, and to me, a battery, everybody thinks is lithium ion, lead acid, maybe electrolyte batteries. That's true. Thermal batteries. Another battery is for me to take everything I need to do in computation and move it to a point in the day when there's zero carbon on the grid. That's a different kind of battery if we want to think about it as storing workloads, not just electrons. So we can look at it and say, okay, the grid is right now 12.6% below its normal carbon factor. Go fire up some of our compute. So this is where we're headed. And of course, as Steve pointed out, the prices fluctuate. There's a high correlation between low carbon and low price right now, because the marginal cost of wind and solar is pretty much zero. So now you start to tie these things into energy grid systems and say, well, if I know my carbon balance and I can look at the market pricing, now I can start to shift load all over the place. So we have an operational goal here, which we've already exceeded, 50% wind, solar, and hydro, 60% the next decade. But the real thing is, how do we green grids around the world at scale so it doesn't have to become this really highly complex math model that consumers, and consumers can be businesses, they can be individuals, government agencies, NGOs, academic institutes, have to think about. This is some of the deals that we've done. We just did another deal in Amsterdam, actually, just about a month ago. But we've been looking at this digitization of the grids and then the consumption off the grid. So today, just to give you a sense, almost every building we've gone into and deployed software in every industry, has about a 20% inefficiency. So what we did is we took this thing, and we'd seen all these articles that said you should be able to get 20% savings on energy through the use of digital technologies. This is our corporate campus in the Puget Sound where I live. 145 buildings, 35,000 pieces of mechanical equipment, 15 million square feet, 60,000 people. It's a city. And so we said, what would happen if we actually digitized this? And we were basically spending $60 million a year. So two things about this Seattle to think about. The first is that from an air conditioning and heating standpoint, one of the most temperate climates in the world, right? The temperature does not vary all that much, although the sunlight does. And the energy price on average is about 6 to 6.5 cents a kilowatt hour. So it's one of the cheapest markets in the world. So that's the context under which we went and tried to do this. And we said we had 2 million connection points. We were gathering 500 million points of data a day, and we had no idea what was going on. So we went and orchestrated all this. And what we found is, in almost every place like this kind of place we were sitting, we had simultaneously heating and air conditioning on, but nobody complained, right, because we're comfortable. We had things where people would go up on the roof. They'd put a big, literally a piece of wood in the damper to stress test the fresh air makeup. They'd climb downstairs, they'd check the building, and then they'd leave, and guess what was up on the roof? A bunch of pieces of wood sitting in your dampers, right? This kind of stuff happens all the time, all over the place, but you never know it because people aren't uncomfortable, they don't complain. So with software, we're finding over and over again that you can get about a 20% savings in all of your buildings around the world. I'm going to skip over this in the interest of time, but the same thing happens with microgrids, and I'm going to talk about them in the context in just a second. So water. I'm just going to give you one piece of data on water. I'll let you read these. So basically, 1% of the world's water is available for us to use. But there's something really interesting if you want to think about the intersection of energy and water. And we don't talk about it all that much. About 70% of worldwide water is used for agriculture. So we did some studies in the state of California, and we looked at other markets as well, and it's about the same. What percentage of electricity and natural gas is used to move water around for agriculture? Turns out it's 20% of electricity and about 30% of natural gas in many markets around the world. So if we're going to go after energy and utility and renewable energy, we also need to go after water. If you're going to go after water, you also need to go after agriculture. So we created a tool because most people don't realize how much water they're using and how much risk they have. People have been thinking about energy and carbon. I'll just give you this really quick story, which is we ran this in all of our facilities around the world. In San Antonio, Texas, pretty drought-stricken area, we were using, just think about how much water you would think you might use in a data center. we were using 70 million gallons a year of drinkable, potable water. And we said, that's crazy. Why do we need drinking water to cool a data center? So with a bunch of analytics, we were able to just do some minor tweaks to our environment, and we reduced that number by 56 million gallons per year in one location. So that's the kind of stuff when you look at systems and artificial intelligence and machine learning, these are the kinds of savings that are possible. 5%, 10%, 15% savings are not going to solve our problems. We need multiple systems change at scale, and so how do we use software to go do that? So we created this program about a year ago called AI for Earth. And just in December, we announced an expansion of it, where we're taking, and this program is available to anybody in this room. So we've committed $50 million over the next 5 years to looking at the intersection of artificial intelligence in agriculture, water, biodiversity, and climate change. Climate change includes two things, carbon and energy. So since we launched the program, and it hasn't actually been advertised all that much, we've really looked at giving people access to computing power that they don't have, providing them education, because if I gave you access to artificial intelligence tools today, it's almost like me giving you the keys to a Ferrari and saying, you've never driven before, here you go. Right? So we have to actually educate people on what do you do with this stuff, how do you use it, and then when we think that there's something that's super interesting that people come forward with, we'll invest significantly at Microsoft to actually write a piece of software that we think can change the world at scale. So I'll just give you one or two examples really quickly. So here's the map of the types of things that we're doing. You can see multiple areas. A lot of this stuff is in energy and carbon and climate. I'm happy to talk about some of this stuff in a bit. And for those of you who want to look at an eye chart in the slides later, you can do that as well. So I want to talk about one of the first things that we've done, because I actually think it applies to how you think about energy systems, distributed energy systems, and the land you need if you're actually going to do wind farms, solar farms, and also distributed energy systems at a microgrid. So today, state of the art of aerial photography is you and I can look at a picture, and we go, there's my house, there's the river, there's the curb, there's the roof. All that a computer sees is a blob. It's called 30-meter resolution. Basically, think of a football pitch. That's the level of resolution that a computer sees. So if we wanted to map this area of Denmark, we did it in the Puget Sound, it'll probably take us about 2 years and about $2 million, US dollars. That's state of the art so that public planners can decide how to deal with stormwater runoff, maybe power consumption curves, where to put all sorts of stuff. So we looked at that and we said, well, what if we could use some of the artificial intelligence to train machines instead of people to go do this? So we started in a place called the Puget Sound. I don't know if people are familiar with it. It's in the Washington, D.C. area. It's been highly degraded environmentally. Used to be a big fishing ground. And what we were able to do is we said 100,000 square miles, 2 terabytes of data. It took them 18 months and $2 million to create their map. So we threw artificial intelligence at it using aerial images. And that slide's not in here, but it took us 110 hours, down from 2 years to 110 hours, and we did 180,000 square miles. So now we've actually tweaked the algorithm, and we're going to release it fairly soon. We can do that in about 10 hours. So now imagine that's the kind of transformation that's going to happen in every part. In agriculture, remember I said 70% of water is used for agriculture, 20% of energy, 30% of natural gas. Everybody talks about precision ag. We're going to reduce energy consumption on the farm. We're going to reduce water use. We're going to increase yields. We were actually talking to the European Commission about this earlier this week. What percentage of farms, if you want to do precision agriculture, how do you actually get data in and out of the farms? Turns out, most farms are not connected. You can't get information in and out of these systems in today's environment. Now, farmers will talk about like the fact that they spend tens of thousands of euros a month on connectivity. Because you and I have Wi-Fi in this room, but if we went out to a farm field and we walked any distance away from a barn or a farm, we're out of contact. We don't have the connectivity. So the issue is, how do you take these kinds of distributed technologies and put them in the hands of all of us? Because what we envision in the case of either land use coverage or in the construct of agriculture also applies to energy. So I'll just leave you with this last thing, which is, in Africa, right, there is no grid in many places. India, rural America, all sorts of places, there are people who still do not have energy. And the challenge is, how do you give them energy and connect them to the grid, not just a power grid, but the information grid. So this guy in the previous slide invented this technology which allows us to connect not only farms, but solar panels. So what we've done in Africa and many other places now around the world is we've said, look, if we're going to have micro-generation of energy, either at an individual house or at a community level, we need data about what's happening there. So he took this thing called TV white spaces, which is the unused spectrum on a TV. Turns out there's a lot of it all over the world. And now what we can do is we can get connectivity at 10, 15-mile hops with high-speed bandwidth throughput, so that as we think about the world of microgrids, distributed energy, distributed farming, whatever activities we want, we can actually have the entire world connected at a price point that we've never seen before. So I went through a lot of different stuff, and I just want to sort of maybe bring it all together, which is the speed at which these transformations are happening. I mean, I didn't even talk about this, and this is about how to use photography to transform what we understand. The speed at which artificial intelligence is disrupting every market, including the energy markets, is something that I think we all underestimate. And I get back to this, which is empowering every person and organization on the planet to thrive in a resource-constrained world. I travel all over the world, and there is one resource that is not constrained. And that is human ingenuity and our ability to invent our way out of this problem. So while I respectfully see all the projections that say 2030, 2040, 2050, we won't get to a zero carbon set of energy, I think it's because of people like I work with all over the world and because of what I see and the scale of change. I actually think we can invent our way out of this problem. Thank you.
Thank you.